Okay. So, good. Good morning. We are all set for some not parallelization, some programming now. Okay. And in this class, I will work with sequential code. But even sequential code, if you do not write properly, it is slow. And by some simple tricks, you can make it 10 times faster or even 100 times faster. Okay. So, we will do that first. It also give you ideas about vectorization. I mean, we learnt about hardware. Now we see in software it is bearing fruits. Okay, so what the ideas which we had learned in hardware will be now implemented. Okay, so in this course we will basically program in Python. Okay, but some of you work with C++ or Fortran. So I will also cover some aspects of C++, okay, no Fortran. Okay. So first let us look at Python codes, how to speed it up, or what you should not do. In fact, you should not do certain things. That is what this lecture is about. So I put all my codes so far in Google Colab. And I am going to, after this lecture, well, I mean after this presentation, I will go to Google Colab and run those codes, okay, and I will share them with you, so that you can run it yourself and also modify it for your own. You can download it and you can copy it, and you can now play around with it. You can write more codes, you can do more problems. So play around with it, that is where you will learn. Okay. So let us see what the ideas are, and implementation I will show you in Google Colab live. Because Google Colab I cannot run on PPT, I have to go to the website. Okay. And also I have the timings of the codes, and we will I will just show you and compare. Okay. So the ideas will become very clear, what we should do, what we should not do, how does Python compare with C++, all that will become clear. So we can run Python codes on many platforms, so your own laptop, anywhere actually. Python is OS independent. I mean, it runs happily on Windows, Unix, Linux, Mac, on browser. So I am going to run on Google Colab, as I said, and the CPU when I ran it was this Intel Xeon at 2.2 gigahertz. Okay, so it also has, you can get information about the hardware by using this command. Okay, we will see that when we start running things. So time will be in seconds or milliseconds. So I will actually time is basically in seconds, and there are fluctuations because of various factors. Okay, RAM, this Google has a big RAM, and a lot of people are accessing it. So there will be some fluctuation, but it is around 10%. So the numbers are accurate only up to 10%, or well 90% accuracy. Okay. So this is a one snapshot of Google Colab front end. Okay. So I just took a snapshot and I just put it here. So you can open a new file. It's very nice. How many of you know how to use Google Colab? Great. Okay. So others will have to learn. Okay. So in fact, you don't need to put in your hardware. We can do even GPU programming on this Google Colab. Okay. That's what. So our platform is Google Colab, and I also encourage you to run on your laptop. Don't make big runs, because your laptop will get heated up, and Gopesh has kind of burnt his GPU by running a long run. So laptops are not for making big runs unless your laptop is very sturdy. That means it has a very good fan, it has very good cooling. Otherwise, if you run a program for 2 hours, there is a danger on your laptop. Okay. So, and never boost up the CPU clock on laptop. You can do it on desktop, but not on laptop. Okay. So data size I am going to use, I basically use arrays, and the data size 1D array will be 10 power 8, and a 2D array will be 10 power 4 times 10 power 4. Okay. So let us look at the first code. So this is the full code. okay, Python code. So, here I am going to take an 1D array and do element by element multiplication. Okay. So, this array A, array B, and I multiply element by element, you understand, no? So, C I equal to A I times B I, okay, not no sum, you are not summing up. Okay. It is not also a matrix product like one number, you know. So, A I take column and take a row, that is not, this is element by element multiplication. Okay. So, there we need to import, right. I mean, I am sure everybody is familiar with Python. So, I am going to use NumPy. NumPy has very fast libraries functions actually. Okay. NumPy is a package, and the package the functions of NumPy are written in C. They are highly optimized, and you will see that with NumPy we get a in C, well, the Python gives as good performance as C. So, there is no loss. So, do not use list, okay, for number crunching, do not use list or some slow array data structures. So, this import NumPy is NP, and I will use this library date time. Okay. So, date time will give me time. So, I create two arrays. Do not create arrays with numbers like 1, 2, 3, or because if you put, let us say I put all the numbers to be 2, okay, all A's are 2 and all B's are 2 or 3, then compiler will not make a loop. It simply it knows, it just going to one time and fill up. This is straightforward, no. I mean, so you choose, when you test a code, you should try to use random numbers, so that compiler cannot do this trick. Okay. So, we generate two big arrays A and B of random numbers, and so this is the standard random function part of NumPy, and it has 10 power 8 elements. This is big, okay. I mean 0.1 billion. Now, we create an empty array because I want to store the product. Then now I want to time, no, so time only the loop, do not time the whole program. So, this is the thing we should do in your parallel programs. We should time before, I mean put a timer before and after the main part of your code. Okay. So, the main part of our code is multiplication. So, let us do it with the loop. So, for I in range 10 power 8 and C I is A I times B I, right, that is how you write a loop program, correct. And so, T 1 is before the loop and T 2 is after the loop, they are numbers float. So, the difference will be the time taken for the loop, okay. And okay. So, that is one way. In Google Colab it takes 48 seconds on that particular hardware. Okay. I did CPU info, I got this Xeon processor, and it took 48 seconds. Now, let us do the same thing with this vectorized operation, okay. C is A star B, and again I time it T 1 and T 2, and the difference it is 0.36 seconds. Okay. Now, the speed up is more than 100 times. Okay. So, in fact, this code is simpler, it is just one line. I do not need to worry about loop, range, no new variables. So, this power of vectorization, it is better and shorter. So, always use vector operations for your programming in Python. Okay. So, if you have a ODE solver, so we have Newton's equation, well, do not do Newton's, do not, I am not looking at Newton's equation, but V dot equal to V minus V squared. Okay. So, write V as a NumPy vector, and your time stepping should be in a vector operation, do not do a loop for the vector elements, for V. In time, of course, we need to loop it, but for V you should use vector operation. You understand what I am saying? So, V t plus delta t, I make an array, no. sorry, I made a mistake. This for one variable, I want a vector. So, this is a vector, that means lot of elements, and this is also a vector. So, this V I will be V I t plus delta t times V squared at I. This I is a index of V. Okay. So, V is basically in that it could be 1000 numbers. So, 1000 variable differential equation. So, it is a not single differential equation, but 1000 differential equation. Okay. Now, some people will say, well, let us put a for loop for I equal to I in range 1000. So, that will cover all i's from 0 to 999, but that is a very bad thing to do. Do not do that. So, you declare V as an array, and then we just write, do not put this i's. Okay. So, you should write like that. So, do not use a loop for arrays. Now, in my Mac I had done it before, which is 6. Okay. It has 8 cores, and these numbers are here, which is comparable numbers. Mac is faster. Okay. This was a better CPU. So, I am just showing you to compare. So, I want you to try this in your laptop. This won't burn your laptop. Okay. So, this is simple one, and you should do it locally as well, because you need to write a big program that you have to do locally. It can't, well, some of it you can do in Colab, but you should know how to do it not locally or HPC. No? So, HPC is not Google Colab. Now, let us do 2D arrays, 2 dimensional arrays. Now, so these are 16 numbers you can see in the screen. Now, these 16 numbers, how are they stored? So, this is 4 by 4 array, right. So, in memory there are 16 float locations, right. Each float is 4 bytes, 8 bytes. So, total there are 64 times 8, that many bytes of storage. Now, first one is definitely 0, second one is what, 4 or 1 in that when I look at memory. So, this is 0 for sure. Okay. First is 0, second number is 1, it will be all in a line. In RAM they do not make this matrix, even 3D array will be made in a line. Okay. So, you go either this way or this way. So, next number is what, 1 or 4? 1. In Python it is next number is 1. So, it goes this way. So, this is a row index and column index is here. So, row moves slowly. So, this is row 0, row 1, row 2, row 3, and this is column 0, column 1, column 2, column 3. So, the numbers are stored called row measure. Both C and Python store row measure numbers in a row measure format. So, it will be 0 0, 0 1, 0 2, 0 3. First finish first row, then go to the next row 1 comma 4, 1 comma 0, 1 comma 1, like this. Okay. So, you can see that the column index is running faster than row index, and similar thing happens for 3D as well. 3D, the first 2 index will run slower and the last index, rightmost index will run faster. Okay. That is how is a convention followed in C and Python. Most of the modern languages follow this convention. Fortran does not follow this convention. Fortran follows column measure convention. So, numbers are stored as 0, 4, 8, 12. So, it will be the row index will run faster. Okay. Since we will work in C or Python, we will not worry about Fortran stuff. Okay. Now, when I do a loop, let us imagine that I have to do a loop. Sometimes vectorization is not possible. Imagine that there are some conditions. So, these numbers have to be treated separately, or last row. Well, we should always find a way to avoid if, but for some reason, well, you should know how to, if there is a loop, then what do I do? Should I make, so there will be, I mean, you know, I am sure you have done programming, this one for sure, for I equal to 0 to 4, for j equal to 0 to 3, sorry, 0 to 3. So, the I should be row or column. So, I will write C I in C equal to A I A j star B I B j. In Python I will do C I comma j, right. So, what so should I put like this, or should I put instead of I put, I interchange j and I. Okay. So, which one do you want to do, first I then j, or in the loop? So, one option was I j, second option is j I, just change of loop, right. Which is better, j I or I j? I j is better, because I want to. So, memory access, remember memory access, how does the CPU go and fetch data from memory or for even from cache? It will try to get numbers, chunk of numbers in one shot and work on them. Vectorization requires that your numbers are consecutive numbers. If they are not consecutive, then well, I got 8 numbers, but I only use 2 of them or 1 of them, waste, right. If I got 8 numbers, then I should operate on 8 numbers. So, what will computer do? It will take a chunk from memory which are consecutive and bring it in. So, the number consecutive are for a given row all columns. So, I index should not run faster, I index should run slower, j index should run faster. So, the data can be brought in memory in a consecutive manner. So, my cache efficiency and memory efficiency is better. This simple idea which we know from hardware, there is no any magic stuff, it is what happens, and you can see the numbers. So, this is there are 2 loops. Okay. Initialization has already been done. Okay. So, I am not going to put all of it. So, we do one loop when I is first and j is second, right, and this is the number, and the second one is when j is first and I is second. Now, let us look at the numbers. Well, when I ran on Mac some time back, it is 2-year-old number, this the difference was very large, okay, 53 and 1.12. So, by the way, in Python this is goes as 1:12. This 1 is a minute and 12 is a second. Okay. So, actually the numbers are not very different. Okay. So, this will be how many? 72 seconds, 53 versus 72 seconds, and this number. So, this is not very large, I am sorry, I 53 and I think 1.12, that is not true. This is 1 minute 16 seconds is 1 minute 53 seconds. Definitely j I is slower, but I believe this interpreter is clever. Though it is j I, it is flipping when it is computing it. Okay. Otherwise, these numbers will be pretty bad. So, when we look at the C code, they will say I show you the number, it is not as good. J I is much slower. So, this is where you can see the compiler, by seeing your code, it is able to optimize it without you. I mean, it is basically forgiving you. I mean, you made an error, but okay, I will do it better. Okay. Assistant is applying its logic. Anyway, so this was not so bad. I mean, j I or I j is okay, but I should not do like that, right. I mean, I should use vectorized operation. This will be vectorized, but not efficiently. These are all vectorized. Okay. This is loop is also vectorized, but the better thing is to just use A star B, and the number is for Colab is 0.38 seconds. So, this is definitely something like 3 times faster compared to 1.1:16. So, this is not 10 times faster like what you got for 1D, but this is still faster for 0.38 seconds. Now, I have not dug too much into compiler, I do not have time, but these compiler designers who are very clever people, they see how to optimize these operations. Okay. Okay, now this is with the loop with if statement. This I would say that we should avoid it, but I find that the penalty is not very much. So, I j, but this is I mean this product I just put a condition. If it is greater than 0.5, then I take a plus sign, and if it is less than 0.5, then it is minus sign. Okay. And the same 10 power 8 numbers. By the way, please keep in mind the total numbers are 10 power 8, 10 power 4 into 10 power 4, and this is 1:44 seconds. So, 1 minute 44 seconds, which is comparable to earlier one. So, these are all optimized by compiler. Okay. So, there will be some trick which there is doing it and to get better numbers.